so I'm going to just go over a number of features of Coccinelle. So we'll talk about the structure. So I'll do some of the things that you did already, just to sort of get going again. The structure of a symmetric patch, isomorphisms, which you talked about also. There's an annotation which is called depends on. Dots, which you talked about. Nests, positions, and the use of typo. So the structure of a symmetric patch. So basically the idea is we want to specify patterns of code to be found and to be transformed. We want to search, we want to transform. We want to specify which terms, in doing this, we want to specify which terms should be abstracted over. So that's the meta variables we talked about. And as Gilles made a big point of, we want a C-like, patch-like notation that should somehow be easy for people who have C to get started on using. So this is the same example we saw before. The point is we want to find occurrences of this. And the important parts are the exclamation point and the ampersand. And then we would like this just to be any arbitrary expression. And this should be any arbitrary constant. Okay, so I say the constant just because that's what I've noticed that the problem occurs most of the time with. If you wanted, you could experiment with this being some arbitrary expression. Sometimes people, the smart board we will not go with.
I think there's people
Okay, I just wanted to make the point. Sometimes people do not X and not X, not Y, something like that, and they really want to do an AND of two Boolean values. And it's a bit strange why they don't do this, but at least it's not actually semantically incorrect. So the point is, if you do the more general case, then you might have some false positives that you have to check for. So in some sense, it's useful to first work on the more specific case and then work on the more general case after that. So a nice thing about Coccinelle is you can try one pattern that might be very specific, or maybe you can try one pattern that's very general and see that, oh, you're getting a lot of false positives, this is really a nuisance. So then you can try to make it more specific in some way and then work back up to where you started again afterwards. So this is the rule that we saw before. We have the rules, they have two parts. There's the meta-variable specification. And you can think about what kind of constraints you would like to put on your different meta-variables. So here I'm saying the first one, E should be an arbitrary expression, but C should be a constant. And a constant is either a number or because in C mostly, sorry, not in C, in Linux code at least, people, when they make constants using hash define, they mostly have capital letters. So we also recognize identifiers that are only in capital letters as being constants as well. So those are the meta variables, and then we have the transformation specification. We say we would like to remove anything that looks like this and replace it with something that looks like that. So you can make just one rule, or you can put a whole bunch of rules together, and then it will do them one at a time. So I'll talk more about that. So meta variables, what kind of meta variables can you have? Expression is an arbitrary expression. But you can also say you would like an expression of type integer, or an expression of pointer type, or a specific pointer type, and so on. So you can take any type from the source program as well as an expression. You can say it's a statement, a type, a constant. So this is a local ID expression, so this is quite specific. This is a identifier that's going to be declared in the current function. And for transformation specifications, you can say that something should be removed, something should be added. And then what we wanted is sometimes you don't want to actually change anything, you want to just find things. And so we have star for I just want to find something. And in one specification, you can't mix these. So you can have minus and plus together, but you can't have star. You have to decide between one or the other. And as Jill mentioned, spaces, new lines, and so on, they're all irrelevant. So we make an effort to try to, when we generate code, for example, we try to fit with somehow the function that's around the generated code. But we're not always successful. Probably printing is the hardest thing that one can do in making a transformation system. So sometimes this doesn't come out as well as one would like. So now you get to try experiment all by yourselves. So there's two functions in Linux. These are basically getter and setter functions. ID get with data just returns access to the with data field, and ID set with data, it has an assignment to the with data field. So the goal is to make a rule that will search for occurrences of with or with data. Actually, with is not the identifier you should be looking for. You should be looking for any arbitrary expression of type of this type. And also, you want to find assignments like this. Data, you should look for assignments like this, and data should be an arbitrary expression. If you find an assignment like this, you want to replace it by a call to this function. And if you find just an expression like this, then you want to replace it by a call to this function.